Hello, my name is Sarah, and today I will be teaching you about a bibliometric indicator called the H-index. First, what are bibliometrics? They are quantitative indicators of scholarly articles, journals, authors, and institutions that aim to assess research productivity, collaboration, and impact. Bibliometric indicators such as the H-index or impact factor are frequently applied in academic promotion and funding decisions and can make or break researchers' careers. Still, many academics do not fully understand how bibliometric indicators are calculated or the many factors that influence them. In this video, I will teach you about one of the most used indicators in bibliometrics, the H-index. I will describe what it is, how to calculate it, and explain how it is used. Most importantly, I will address the limitations associated with using it. By the end of this video, you will be able to define and calculate the H-index and be aware of its limitations. The H-index was created in 2005 by physicist Hare with the goal of creating a metric that would combine an author's number of publications and citations. The H-index is widely used, probably because it is both simple and widely available in many databases like Web of Science, Scopus, or Google Scholar. The H-index is often used in decision-making for hiring, promotion, tenure, funding, and academic prizes, either directly integrated into the selection process or used behind the scenes by committee members. Let's discuss how the H-index is calculated. The H-index focuses on individual authors and aims to combine their scientific productivity and impact using two variables. The first is the number of publications an author has published, and the second is the number of citations those publications have received. Therefore, a scientist has index H if H of his or her number of papers have at least H citations each, and the other papers have less than or equal to H citations each. Since an author's H-index can never exceed the number of papers they have published, the number of publications is the limiting factor. On the other hand, an author needs to have many publications to get a high H-index, but a high number of publications will not automatically result in a high H-index unless they are also cited frequently. In this example, author A has an H-index of 5. This means that they have published 5 papers that have received at least 5 citations each. Even though author A has published 20 papers, the H-index ignores any publications with less than H, in this case 5 citations each. Likewise, citations above H are also not considered in the calculation of the H-index. This means that the 120 citations received by one of their papers do not affect the H-index at all. Author B also has an H-index of 5. Although they have published only 10 papers in total and are cited less frequently, they have the same H-index as author A because both authors have published 5 papers that have received at least 5 citations each. Now that we have discussed what the H-index is and how it is calculated, it is important to consider some of its limitations. The quantitative indicator based on the number of publications and citations, the H-index, like other bibliometric indicators, is not an accurate measure of research productivity and impact. It is also important to note that the H-index does not account for differences between research fields. Academic disciplines have different publication and authorship practices. While fields such as engineering often include several, sometimes dozens of authors on a publication, authors in disciplines such as English or history tend to work alone. This affects the average number of publications per author. The extent to which researchers publish in books rather than journals also differs between disciplines. This influences the number of publications commonly captured by the H-index. The length of reference lists also varies from one field to another. This directly influences the average number of citations per article and therefore the H-index. Disciplinary norms and publication practices affect the average number of publications per author and citations per paper, causing H-indexes to be lower in some fields than others. Since the H-index does not account for these field-specific differences, it should never be used to compare researchers from different disciplines. Consider Dr. George Clark, who has been an active researcher in English literature and a full professor at an English department in the UK for over 30 years. He has an H-index of 5. George wants to apply for his institution's prestigious Researcher of the Year award. He read online that an engineering professor with an H-index of 45 received the award last year. Like all bibliometric indicators, the H-index depends on the database used to compute it. The more publications and citations a database indexes, the higher the H-index. Databases such as Scopus and Web of Science, as illustrated in this visual, will rely on different sets of publications and citations to calculate the H-index, meaning the H-index of the same author may vary across databases. Here we see Dr. Maryam Hashemi, a postdoctoral fellow in biotechnology from Iran. Maryam knows that in her field, the H-index plays an important role in hiring and promotion, and is therefore debating whether or not she should include it in her CV when applying for a faculty position. She has 5 peer-reviewed publications, of which one is cited 291 times. Maryam is really proud of this paper because it's her first author journal article, and it was published in a very important journal in her field. Maryam has 4 other papers. One was cited 12 times, another was cited once, and the other 2 were just published and have not been cited yet. Since she has 2 publications that received at least 2 citations each, her H-index is 2. Maryam feels like this number does not reflect the impact of her work, and that it is unfair to early career researchers like her. So, what have we learned about the H-index? To recap, you now know that the H-index is calculated by somewhat arbitrarily combining an author's number of publications and citations. You have learned that the H-index, like many other bibliometric indicators, is influenced by field-specific publication and citation practices, as well as database coverage. You also learned that due to its dependency on the number of publications, the H-index cannot be used to assess early career researchers. As a quantitative indicator, it does not accurately measure an author's productivity or the quality of their research. However, due to its popularity and simplicity to calculate, the H-index is one of the most widely used scholarly metrics. Ultimately, one quantitative metric will never be able to fully capture a researcher's work. If used at all, the H-index should only complement qualitative research assessment. When you encounter the H-index, it is imperative to understand its limitations and engage with it critically.